Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket for chi-squared goodness of fit. Our scenario is bloodsuckers, so let's look back at this. We ran the test in a previous video. So, a genetics researcher wants to determine whether the frequency of different blood types in a town with a population of 3,550, so there is a population, is consistent with expectant frequencies based on the Hardy-Weinberg equilibrium. In other words, is it the same? The researchers randomly select the researcher randomly samples 200 individuals, so there's our sample size from the population and records their blood types. He observed 85 with type A, 31 with B, 8 with AB, and 76 with type O. The Hardy-Weinberg has the following blood type: 36% are A, 12% were B, 3% were AB, and 49% are O. So that's the expected percentages. And we put those into the calculator. In L2. So there's our L1, those are our observed values. L2, we have expected percentages, but to get the expected values, we went blue 2 times 200 because we needed to go the sample size times the percentage, and we got our expected values. So these are our expected values right here. All right, so that was setting everything up. And it says which blood type, A or O, had the greatest contribution to the chi-squared statistic. Well, let's go ahead and run the test and find that out. So stat test, chi-squared GOF. Oh, categories 4 minus 1, because we have 4 blood types, 1, 2, 3, 4 minus 1. And we ended up getting, these are our contributions, 2.34, and that was for type A. 2.04, that's type B. 0.666, that's AB, that's the devil. And then 4.938, which is type O. So, which one was the biggest? Well, clearly type O because it has the largest value. And it says show the calculation for that contribution. Well, our chi-squared formula is observed minus expected. So in this case, we're going to go 76 minus, what did we expect? 98. So this was my observed, this was my expected. And when we did that, we get 4.9387. So let's try that out, make sure that it really worked. So 76 minus 98 squared divided by 98. And sure enough, we get to 4.9387. All right, so that took care of that part. How many samples are there? One sample. We took one sample of 200 individuals, list the variables and levels of each. All right, when it came to the variables, our variables were, we only had one variable, and it was blood type. It also asked for the levels. Well, how many types of blood types were there? 1, 2, 3, 4. So the levels in this case is 4. All righty. Appreciate you watching. Look forward to seeing you on the next one. Thank you.